As promised, after static routing, we'll cover dynamic routing, or better known as routing protocols. I remind you that the goal for this course is to explain these things as simple as possible and focus more on the practical examples rather than theory. In this section, I will certainly keep it simple and then add more complex exercises into the bonus section. The course will, however, be published before the bonus section is filmed, so if you're an early bird, I kindly ask you to be patient. Also, if you have ideas for exercises that might be interesting for me to resolve and publish here, go ahead and send them to me. They might just show up in the bonus section when you least expect it. Okay, let's get into RIP now. RIP, first of all, short for Routing Information Protocol, not Rest in Peace, is one of the older routing protocols, but it's still good enough for smaller networks. It doesn't consume much of CPU and memory, so it might just be a perfect pick for a small to medium network with older equipment. And it's still tested on Cisco certification exams. Let's look at some facts that will be useful to us while configuring RIP. First, the routers using RIP as their routing protocol will send their entire routing table periodically. This value can be changed, but by default it's 30 seconds. If you keep this default value of 30 seconds, you should also keep the default value of 180 seconds, which is the time a router waits for this update from its neighbors before it assumes the neighbor is disconnected. If a neighbor disconnects, that means you'll lose some routes, at least those routes going through that neighbor. That results in a recalculation of routes, after which your router will again send out its routing table to its neighbors, or to what's left of those neighbors. Another important thing to remember with RIP is that its main metric is number of hops. It doesn't consider the speed of a link or latency, none of that stuff. It will simply look at the number of hops, and whichever route is shorter, it will win. And in the end, administrative distance for RIP is 120. We will see that in our exercise. Now let's discuss the versions. Obviously, RIP was created a long time ago, so long ago that in those times classful addressing was still used and believed in. And as a consequence, the first version of RIP did not even send information on subnet masks. Luckily, a second version was created which did support the transfer of information on subnet masks, and that is the version we will be using. How to configure RIP? First, you say router RIP. Then, you specify the version. If you were to time travel and use version 1, you wouldn't need to specify it. Next, as in every other routing protocol, you need to list all of the networks on the given router. This will be more clear in the exercise, but in short, by listing all the networks on a given router, you're telling the protocol these are the networks you need to tell your neighbors you have. So if each router announces all the networks it's connected to, and it communicates this information to its neighbors, and the neighbors propagate that information further, eventually all of the routers will know how to reach all networks in that domain. They will simply look at who sent them which networks, calculate the hops, and populate their routing tables with that information. And if you wanted to disable RIP, just type in no router RIP. That's this command at the bottom of the slide. Two more commands: passive interface and no AutoSummary. For passive interface, imagine this situation. You have a LAN network using any routing protocol. This can be used in other protocols as well. So you have a, let's say, corporate network and it uses some routing protocol. This means that all routers in that network, including the gateway, have a full routing table of that corporate network. But do we need to send our internal routing table to the outside? Not really. Same goes for LAN networks in which there are no other routers. You can configure passive interfaces there as well, and we will do that in our upcoming exercise, so it will become clearer soon. The other thing, no AutoSummary, since we won't be typing in subnet masks in RIP, we'll use the no AutoSummary command to make sure that RIP doesn't use the default IP address classes. There will be a lesson on summarization later on, and it will be clearer what that is. You can try on your own in the same packet tracer file provided for the exercise to configure RIP with and without this command. It will work, so your communication will work when you test it, but you will see these class A, which is a /8 mask in the routing table, as well as the original masks. Okay, that's enough of theory. Let's get to the practical part now.